Hello everyone. So in this video series, we will be covering on the concept of equilibrium in a 3D system. So sebenarnya tak ada banyak beza sangat this 3D system with coplanar system. Cuma the additional consideration included in a 3D system is that the summation of force in z direction should also be equivalent to 0. Itu aja penambahan dia. Kita tengok example terus sajalah, senang sikit. So in this example, given a 3D system and you need to find what is the force developed in each of the cable to support the 40 kilonewton crate. So there's a load over there with the weight of 40 kilonewton. So you have to find what is the force for each cable. Nah, kita check dulu ada berapa cable in this 3D system. So there's one cable connecting from point A to point B, and then there's the second cable connecting point A and point C, the third cable connecting with the crate, and the fourth cable connecting with point D. The one connected to the crate is bounded by the weight of the crate. So kita tahu weight of the crate is 40 kilonewton. So we don't have to find what is the force of this particular cable. So the remaining cables left in this system would be cable AB, and we need to find the tension force of FAB, and cable AC, and also cable AD. So we need to find the tension force of 3 cables. So kita tahu the tension of the cable connected to the crate is subjected to the weight of the crate. So given the weight of the crate is 40 kilonewton, so that is our tension force over here. The big question now is how do we get the forces of all the cables in this 3D system? So let's look at this system carefully. Kita boleh tahu coordinate B, C and D. So probably we can find the position vector, and then later on we can find the vector of the forces using the unit vector punya relationship. Remember, recall from chapter 2 punya lecture. So you can use a formula of force vector equivalent to the magnitude of force multiplied with the unit vector, whereby the unit vector can be calculated by dividing the position vector R with the magnitude of the position vector. So in this case, the first step of the analysis, you need to find what is the position vector, and then you need to find the magnitude of the position vector. Okay, let us first solve for cable AB dulu. So first step, cari coordinate of point B. So kalau kita tengok at this 3D system, the coordinate of point B would be -3 because it is at the negative direction along the along the x-axis, and then -4 along the y-axis, and +8 along the z-axis. So if we rewrite this coordinate in a Cartesian vector form, then the vector RB would be equivalent to -3i minus 4j plus 8k. Next step, kita boleh kira the magnitude of the position vector, whereby the magnitude is equivalent to component along the x-axis, which is -3 squared, plus with the component along the y-axis, which is -4 squared, plus component along the z-axis, which is 8 squared, and then you square all the summation. Simply use your calculator and you will get the magnitude of component position AB to be 9.4340 meter. Okay, when that is done, we can straight away formulate the Cartesian vector for our force by using the magnitude of force multiplied with the ratio of the position vector as shown. Okay, so at this point, force magnitude of force along the AB cable is still unknown. Tapi kita dah tahu the position vector punya value kan. So along the x-axis is -3 divided with the magnitude, which is 9.4340, and then that is along the I direction, and then you minus with position vector along the J direction, which is 4, divide with magnitude, which is 9.4340, that is along the J direction, and then also you tambah the ratio at the K direction, whereby the magnitude is 8 divided with 9.4340. Okay, you try to simplify the ratio and this is the first equation that you will get. Okay, nampak banyak sangat numbers dekat sini kan? Okay, relax, chill, jangan panik, pegang dada, you cakap all is well, all is well. At this point, you just leave this equation as it is. You proceed in solving for the AC cable pula. So again, find the coordinate of point C. So simply, kita boleh tengok our point C, it would be equivalent to -3 along the X direction, and then it would be +4 along the Y direction, and +8 in the Z direction. And then you redefine that coordinate in a vector form or in a Cartesian form, and you will get a value of -3i plus 4j plus 8k. Sama je step. Accordingly, cari the magnitude for the position vector for cable AC, and then sama macam step sebelum ni, create a new vector equation for force along cable AC. Step dia sama je macam step sebelum ni. So, I'm going to fast forward this particular section. Okay, you should try this on your own. This may look very confusing, but relax, jangan panik, bertenang, all is well, all is well. So you just proceed your further analysis by solving for the third cable, which is for cable AD. Step dia macam mana? Sama je macam sebelum ni. Cuma uniknya position D is we don't know what is the coordinate of position D. So, we just represent the coordinate with a value. So, sekarang ni kita tahu the dx lies along the x-axis only. So, the coordinate will be dx 0 and 0. So, the corresponding position vector would be dx along the I direction je. Kenapa tak ada direction dekat J and K? Because it's 0. And then boleh tak kira magnitude for the position vector of AD? Boleh lah, the value would be the same with dx sebab dia ada satu direction sahaja, which is dx. So, accordingly, generate the equation for the force vector by multiplying the magnitude of force AD with the unit vector. So, unit vector kali ni ada dx over dx in the I direction sahaja. So, the final equation would be FAD along direction I sahaja. Okay, sekarang ni you dah generate 3 equation. The first equation, the second equation, and the third equation. Before we proceed, kita jangan lupa ada satu lagi cable dalam 3D system ni, which is a cable which support the crane. So, you generate the Cartesian equation for this vector as well. So, as it is only acting along the Z direction, so we know that the F crane for this particular cable would be -40 K. Kenapa negatif? Because it is pointed downward. Kenapa K? Because it happens along the Z-axis. Okey, sekarang barulah kita boleh merungkai misteri sistem ini dengan menggunakan equilibrium condition. So, in order for you to solve for the equilibrium condition, you have to solve it according to its respective direction. So, in this case, kita solve along the x direction first, which is all the magnitude in the I direction as shown. Sebab tak muat, I'm going to continue my jalan kerja in a new sheet. Okay, so in equilibrium, assuming that the rightward direction is positive, so we have to make sure that summation of all forces in x direction should be equivalent to 0. Okay, remember the magnitude of the I direction yang saya lukis square box around it? According to this equilibrium condition, summation of the magnitude in x direction should be equivalent to 0. So, you rewrite all that magnitude in this particular equation. So, kita ada -0.318 FAB minus with 0.318 FAC plus with FAD. Okay, that summation should be equivalent to 0. So, dalam equation ni ada 3 unknowns, which is FAB, FAC and also FAD. It's okay, we just leave it as it is. Okay, kita continue our equilibrium analysis in the y direction pula. So assuming the upward direction to be positive, then summation of all the force magnitude in y direction should be equivalent to 0. Tengok balik dalam equation yang you generate sebelum ni. Okay, you kumpulkan all the magnitudes in the y or the j direction, which is this one and also this one. Ada lagi tak? Oh, ada dua je. So that would be nice. So we rewrite that magnitude into our equilibrium equation here, whereby negative 0.424 FAB tambah 424 FAC, and that would be equivalent to 0. Okay, now you repeat the same equilibrium condition for the z direction pula. So assuming the upward direction to be positive, then summation of all the forces in z direction should also be equivalent to 0. So you sum up the magnitude of this one, and also jangan lupa the weight of the crane over here. Okay, so I'm going to rewrite the summation of the magnitudes along the k direction over here, and this would be my third equation. Okay, saya boleh rearrange this equation supaya we are left only with the unknown variables on the left side. Now I have three equations. This is going to be equation number 1, equation number 2, and equation number 3. So if you look at equation number 2 and 3, variables are sama, which is FAB and FAC. So I'll try to solve these two variables first from these two equations. So I'm going to multiply equation 2 with 2, so that dia punya value dekat depan tu sama dengan equation 3. So the corresponding equation would become negative 0.848 FAB plus 0.848 FAC, and that is equivalent to 0. So let's call this new equation to be equation 4. If I want to cancel out FAC, so kita tolak equation 3 with equation 4. So kita bawa turun 0.848 FAB minus with negative 0.848 FAB. And then for the second expression pula, 0.848 FAC minus with 0.848 FAC. So from this equation, you can actually cancel out the FAC. Okay, you are left with only one unknown, which is FAB, which can be solved very easily. So the final value for FAB would be 23.5849. So check the unit berapa. So given the weight of the crane in kilonewton, so by right, all the magnitudes in our equation would be equivalent to kilonewton jugalah unit dia. Okay, so that is our magnitude for FAB. So you can substitute the new value of FAB into either equation 2 or 3. So let's see, if I were to substitute this value into equation 2, then I can solve for the value of FAC pula, whereby I will get a value of 23.5849 kilonewton. Okay, nice. Now kita dah dapat the value for FAB, kita dah tahu value for FAC, so we can easily calculate the value of FAD by substituting these two new values that we calculate into equation 1. So simply solving for this equation, I will get the new value of FAD to be 15 kilonewton. At the end of the day, it would be nice if you can summarize all your calculations in a nice statement like this. Put like, therefore, forces on each cables are FAB equivalent to 23.6 kilonewton, FAC is also 23.6 kilonewton, and your FAD is 15 kilonewton. So you recheck with what you need to find, and there are 3 items that you need to find, and there are 3 magnitudes that you managed to find. So you're good to go.